Hi guys, how are you? I will use this video just to answer some of the questions you were sending to me. Of course, some of you started to do the model quiz, and there's a lot of questions. The most important, how to how to find an angle when you have this expression here that you know a, you know the value a, but you don't know the angle, of course. You know this, but you don't know the angle. You want to find the angle. How you can do that? Well, you just have to apply the reverse function of sinus. In your calculators is given by sinus to the minus 1. Okay? So if you apply that to a, you will find the angle, and that's it. So in your calculators, let me show you a picture of a calculator here. First, please be sure that you're always working in degrees, okay? Not in radians. So in this calculator, for example, here we have the trigonometric functions, sinus, cosine, and tangent. And if you see up here, we have the reverse functions, sinus to the minus 1, cosinus to the minus 1, tangent to the minus 1. Okay, so in this calculator, I have to press first this button here, second function, and then I press sin, and it will apply that. Okay. More of the In most of the calculators, it's similar than this. You have to maybe press some kind of shift and then sinus, and that's just have a look above your k that it's for sinus. Okay, and that's it. So that's actually very you gonna need that actually to calculate the critical angle when you want to know if you're gonna have or you will not have a total internal reflection. Okay, the critical angle is given by this. How is that? Let's have a look. Let's remember. Okay, so we have a ray that is coming, let's say, from the water to the air. So then we will have the first condition for total internal reflection there. First thing we have to do what it is to draw the normal. Okay, so yeah, this is gonna be the angle of incidence. But if we want to know if we're gonna have total internal reflection or not, we have to, first consider that we have our array that is gonna be the array that has the critical angle. And remember what we have. How can we get to total internal reflection? So the critical angle is when the ray of refraction, the refracted ray, it's right in the surface, parallel to the surface, is going there. It's not going like that anymore, but it's going there. Okay, so what's there? Which angle is doing with the normal? The normal goes this way too. Let's change the color. The normal is the angle with the normal is that one. That's 90 degrees. Okay, we're looking this way. So of course you will remember the Snell's law. Let me write it here. And 1 multiplied for I will do it with my hand. Sorry. And one sinus of, let's call it critical angle, it's gonna be, and two sinus of how much? 90 degrees. So you will remember that sinus of 90 degrees is equal to 1. Okay? So then you're gonna have that sinus of the critical angle, it's equal to n2 divided by n1. Be careful with n2 and n1, the index of refraction. N1, of course, is gonna be the index of refraction, where is the ray of incidence. In this case, it's in the water, so it's gonna be the water. And n2 is where is the ray of reflected ray. Okay, in this case, it's gonna be air. So look this expression here on the right. Sinus of the angle, critical angle, it's equal to the index of refraction 2 divided by the index of reflection 1. Okay. So if we apply the reverse function to this, we're gonna get this expression here. Okay. So it's that's all. It's very easy to calculate the angle, critical angle, because you just need to know the index of refractions that normally you have them, and you don't need any more. You just need to apply this sinus to the minus 1 to that expression. Okay, so in this case, let's calculate the critical angle between for a ray that is going from water to the air. Okay, so n2 is gonna be the air 1, okay, divided by the index of refraction of water, which is 1.33. Okay, that's 0.752, let's say. Okay, that's that little expression here. So let's apply the reverse function to that number. Okay, so in this calculator, second function, and then I apply sinus to the minus 1. Okay, what it says there, 48.7 degrees. That's the critical angle for when you have water and air mediums. And remember, I told you that the index of refractions are constants, so that's the critical angle always when you have a ray that is inside the water and it has a surface with the air. Okay, so that's it, guys. Let me know if you have other questions. Well, just another thing, we say that the angle of sinus of 90 is equal to 1. Well, of course, if you apply sinus to the minus 1 to 1, which angle you're gonna get? 90. Okay, so I recommend you to do that to when you're using for this first time this function in your calculator. Press 1 and apply the reverse function for sinus to the minus 1. 90. Okay, we're doing things right. Okay, that's also will help you to see if you are working in degrees or in radians. Okay, it has to be say 90. If it doesn't, it's because maybe your calculator is in radians. You just have to switch it to degrees. Okay, I hope that's helpful. Let me know what else you want to know in the next 20 minutes and I will respond that. Okay.